A composite image is made from combining two or more images into one. So far, everything we've dealt with has been opaque, but it's also possible to have transparency, and the level of transparency can be set for each pixel inside an image. Along with the red, green, and blue values of a pixel, there is also an alpha value. The alpha value can be any of the same numbers that colors can be. That is, if the red value can vary from 0 to 255, then the alpha value can also vary from 0 to 255. The alpha value controls the transparency of the pixel. An alpha value of 0 indicates complete transparency, and 255 makes pixels completely opaque. The example program for compositing is basically the same as the ones in the previous two lessons. It has a canvas displaying an image at the top and a row of buttons across the bottom that make changes to the display. Let me start by showing you how the canvas is set up. The constructor gets an image to be used as the background. The size of the image is determined, and the image itself is stored to be used as background. Then the two methods are called, one to create the background and one to create the foreground. The background is a buffered image object. The graphics 2D object is used to draw the image onto the new buffered image object. The foreground is made up from an image created inside this program. A new buffered image object is created, and a new font is stored in its graphics 2D object, and this is used to draw a string of 4 large characters into the memory resident image. This is a simple black and white image. The address of a writable raster object is pulled out of the buffered image. This object has methods that give you direct access to the pixels of the image. Now, this loop adjusts the transparency of the pixels. The writable raster object contains the alpha information. The percent value passed in is used to adjust each of the alpha values. The getPixel method is used to pull the information about a single pixel out of the object and put it into the array. The value in the array is adjusted by the specified percent, and the result from the array is then restored into the object. There could have been a simpler and clearer way devised to do this, but again, I'm just the messenger. The paint method, as usual, draws stuff to the window. The first thing it does is fill the window with a background image. Then there is a call to set composite. This call tells the graphics 2D object that the incoming pixels are to be considered possibly as transparent. If you don't make this call, the incoming image will just paint right over the existing one, and the alpha values will be ignored. Finally, a second call to draw image is made to put the foreground on top of the background. And the graphics 2D uses the alpha settings to set the transparency. Now, this method is called to adjust the percentage of transparency in the foreground image. It does this by calling createForeground to create a new buffered image with the alpha values set. This method is called to set the mode that's used to composite the figures. The value that's passed in is inserted into the graphics 2D object with a call to set composite. There are several possible composite values, and I'll be showing them to you here in a minute. Anyway, that's the display setup. This is the main line. The table of names are the names of the buttons that appear across the bottom to control the display. The overall setup of the frame is the same as we've been doing, and the action performed method responds to the buttons. Here are the responses to the 4 buttons that set the percentages. All that happens is that each one of them calls the setPercent method. Remember that this call will cause the construction of a new foreground image with the transparency set according to the percentage value that's passed in. The other buttons all pass special values used in doing the actual compositing. The values passed in are all defined in the Alpha Composite class, and there's a pretty good definition for each one in the documentation for that class. They are actually commands to the Graphics 2D object, instructing it how to insert the new pixels. For example, the clear command will cause the target location to be cleared and nothing new is written to it. With this, if a part of the foreground is to be written, the background is written instead. Otherwise, the pixel is cleared. Now, each one of these has a different way of doing the compositing. The explanations of these operations make sense once you see how things work. So, if you plan on doing some of this stuff, plan on taking a close look at the API documentation in the Alpha Composite class. Here's what the result looks like. Here you see the composited image that's formed from the opaque lettering being written directly on top of the background. As the alpha values are reduced, the foreground image becomes more and more transparent. This is the background image filling the entire canvas, and this is the foreground image. And this is the two of them together with the pixels being painted at 100%, which is opaque. The setting of the alpha value effectively just lets you see through them. You can do this with any two images, or with anything else. Once you set the composite rules inside the Graphics 2D object, you can draw anything you like on top of what is already there. And if you wish, you can change the compositing rules and paint other things.